Uh, hello everyone. Welcome to all. Today with us, Mr. Parth Vyas, who working as a project engineer, Prahar Engineering Private Limited. He has also experience to working with Indian Oil Corporation Limited as a project engineer, and today he going to present a webinar on industrial valve and gauges in the process line. So I hope you will enjoy the session and get something new. Now I request to Parth Vyas to start the presentation. Parth, Parth, hello, Parth. Please unmute yourself.
Now, so audible?
Yes.
Okay. Thank you very much for this great opportunity to share my knowledge with the students of Parallel University who are ready to join the corporate world. And I deeply appreciate your efforts and contributions for arranging such webinars for the benefits of your students. I thankful for the Parallel Alumni Association team for your continuous in touch with students. And in last, Ravindra sir, I am very thankful for having you as my teacher who genuinely guide the students. And thank you, Parul University, for providing me the Launchpad type platform I was looking for to boost up my career, and the journey is still going on. So now, without wasting any time, I am Parth Vyas, a graduate at automobile engineer, batch of 2016, pass out from Parul University. Right now, I'm associated with Prahar Engineering Private Limited as a project engineer. Prahar Engineering Private Limited is working as a vendor with process industries like Indian Oil Corporation Limited, Aarti Industries, Gujarat Fluorochemical Limited, and etc. We will have an overview of the industrial valve, pipeline, and other important equipments used in process industries. So let's begin. So first of all, we will start from what is valve. So generally, the principle of valve is to control the flow of any material. I hope the screen is displayed. Just wait a minute. Sorry for the delay. So what is valve? A valve is a device or object that regulates, directs, or controls the flow of any fluid. It may be gaseous, liquid, fluidized, solid, or slurries. Sir, the slide is visible or not?
No, Parth.
Yeah.
You just again try to.
Yeah, I'm just trying again.
Okay.
Is it visible now? I'm trying again.
No.
Okay. Okay. So now, is it visible now?
Yes.
Yeah. Okay. Thank you. So now let's continue. So as we discussed, what is valve? A valve is a device or object that regulates, directs, or controls the flow of any fluid. It may be gaseous, liquid, fluidized, solid, or slurries by opening, closing, or partially obstructing various passageways. A structure in the body that temporarily close to prevent passage of material or allow movement of fluid in one direction only. In third way, it may be explained as a mechanical device by which the flow of fluid, gas, or loose material may be controlled by a movable part. So So this is the very simple definitions of valve that can be explained in easy manner. So now we go to the next slide, that is types of valve. Generally, there are many types of valves available in process industries, but these are the main types of valve that frequently used in industries. So let's begin with there are globe valve, gate valve, ball valves, butterfly valve, diaphragm valve, plug valve, needle valve, angle valve, pinch valve, slide valve, and control valve and check valve. So now let's go one by one in detail of each one. Here you can see the two pictures. Let me point out. Here you can see the diagram of cross-sectional valve. Okay, cross-section diagram of the valve, that is globe valve. Here you can see it operates by reciprocating actions of these all. So here this is the Ravindra sir.
Yes, Parth.
Yeah, the global is visible or not display?
Yeah, PPT is visible, but the slide will not change. So just press the slide mode and then do the next.
Okay, I'll do it again. Is it visible now?
It's visible now. Do the
Global.
slide view.
Okay, again I'm doing slide view. Okay. It is visible.
Yeah, it's visible, but not in a slide
Okay.
view. It just show the.
Okay, so now let's continue with this view. Okay.
Okay, it's okay.
Yeah. Okay. So you can see the profile of globe valve. Okay, here is a disc located uh, center of the valve, which prevents the flow. Here we can see it operates by reciprocating action of disc or plug. It can be called as a disc or plug. The disc or plug moves away from the seat, thereby stopping the fluid flow or allowing the fluid to flow. Okay, so in this, it want to state that if you reciprocate this way by rotating this wheel, okay, it will have reciprocating motions. So what will happen once it is go upwards, then the disc will allow fluid flow, and whenever it is downward, it will resist the flow. Okay, so the valve seat can be removable. This is removable or also replaceable also. Okay, the valve can be manually operated or power actuated, or maybe automatic actuated. So as we know that wheel may be operated by manually as well. We can place a motor over here, so it will be automatic or manually. Yeah, globe valve are available from 12 mm to 300 mm size, and their temperature, that means working temperature and pressure limits are 550 Celsius and 150 kg per centimeter square respectively. Material of globe valve is carbon steel, stainless steels, ductile iron, brass, and other corrosion resistance alloys are used to construct these valves. So now this was the overview of globe valve. I hope it is understandable. The next is gate valve. Here you can see these both are more similar. Okay, if we just look at over here in the globe valve, the cross section was horizontal. Okay, cross section was horizontal, and the plate or disc was parallel to the flow. But in gate valve, here you can see if the flow is horizontal, the plate will be act as a plate will be resist the flow vertically. That means it provides more sufficient and efficient flow resistance. Here we can see gate valve functions by the reciprocating actions of the disc in its body. As we see in previous globe valve, it was working same. It is used for shut-off operations. In double disc valve, shut-off is good. Definitely, it is resist the flow vertically. That's the reason its valve shut-off is very good. Gate valve is light in weight, economic, and offers low pressure drop. Gate valve is common in chemical process industries because it gives accurate flow control. As we discussed earlier, that it prevents the flow at the vertical angle. That is the reason it gives accurate flow control. Gate valve can be used up to 20 kg centimeter square, up to 675 Celsius. This is given is working temperature. It can be exceed up to it. Material of gate valve is cast iron, carbon steel, stainless steel, ductile iron, bronze, nickel alloys, and etc. So the main difference is that only in this valve, globe valve, the flow is resisted parallelly, and in the gate valve, it is resisted vertically. That is perpendicularly. So now coming to the next valve, that is ball valve. Here you can see on the pictures, it has a cross section of spherical ball. Okay, spherical hollow ball that prevents the flow and allow the fluid to flow. A ball valve has a spherical plug. It is called plug. The spherical plug is controlling element. In this too, the controlling element was disc. Is horizontal. In gate valve, it was vertical disc, and in ball valve, controlling element is ball. Okay, that all plug also. They are widely used in chemical process. It is very accurate. I have seen it personally. It offers good flow characteristics. Ball valve consists of a two-way globe. At the ball rotates between resilient seats. We can see it is a seat. It is opted over here. Okay. Once we move the handle of the ball valve, it will cover the cross sections of pipe. So that means it will resist the flow. And once we slightly open the handle, it will allow the fluid to flow. It is compact and requires low maintenance and zero lubrications. That's the reason it is more accurate, and it's very costlier comparatively. By giving a quarter turn to the ball, the valve can be closed or opened. As I discussed earlier, the valve does not give a good throttling. It can be used for pressure up to 500 kg per centimeter square and the temperature up to 300 Celsius. As we see in the previous valves, it has a pressure capacity up to 500 kg per centimeter square. The previous one was having only 20 kg per centimeter square, and the first one was having only 150 kg per centimeter square. So that is the reason that it prevents more efficiently and reduce the flow, and that is the reason it is costlier. So now let's coming to the next valve, that is butterfly valve. As we know, actually we are automobile engineer, we know that the butterfly valve is used in that our carburetor. Okay, so same function it will apply over here. Okay, in butterfly valve, the controlling element is disc called as blade. Okay, here you can see the profile of disc. It is as similar as the previous globe and the gate valve, but it is working as it is moves on its axis, so it will resist the flow or allow the flow, which rotate in horizontal or vertical direction and allows the fluid to flow. Butterfly valve is suitable for throttling or on-off operations at low pressure drop. Butterfly valve can be the screw type or of wafer type. It is operations can be manual, powered, or automatic. Butterfly valve can be used for vacuum operations. As I told you that we generally butterfly valve use in carburetor where the vacuum is required. It is available in size ranging from 50 mm to as large as 900 mm. The blade or flapper of butterfly valve can be made from rubber, European chlorosulfonated polyethylene, and etc. It is a very simple construction and working, and it is comparatively very low cost. So now next is diaphragm valve. As we know the functions of clutch, in clutch it is also consists diaphragm. So the same principle will be applicable over here. Here you can see in the profile a spring and the wheel is given. Here is a diaphragm which is located over the cross sections of the from the fluid will be flow. It will resist the flow or allow the flow. Here let's see. Main parts of diaphragm are valve are body. This is the body, the bonnet, and flexible diaphragm. This is the bonnet and the flexible diaphragm. Okay, I hope it is understandable and easy going. Diaphragm is lifted up when the valve is open. Diaphragm will be lifted up when this wheel will be rotated up. Okay, the diaphragm is tightly pressed against the bottom of the valve when it is closed. So when the wheel is down, the diaphragm will be closed and it will resist the flow very tightly. That's right. So the in all the valves here we can see from the first resisting element is disc. Okay, in gate valve also the disc, but the the ball as we discussed it's spherical ball types. Okay, that prevents the flow. Next we discuss butterfly valve. Okay, butterfly valve, it's the same principle is applicable over here of our that used in our automobile component which prevents the flow. Here you can see that, just note it down if you want. The whatever the applications is, wherever the minor change happens of in designs, it changes its capacity. Okay, as discussed, globe wall is capable of working under 150 kg per centimeter square. Okay, the gate wall is capable of working under 20 kg per centimeter square. Just changing the way of resistance. Okay, the next that we see that this is applicable for the vacuum process. Okay, that generally used. Okay, now the next is plug valve. See, all the valves are based on same principle to resist the flow. Okay, but the way of resistance is different. In the previous one that we see, they are only using disc. In the next, that your disc is replaced at another vertically or horizontally. Okay, then next we saw that they replace the disc and put a spherical two-way spherical ball. Okay, and they applicable they utilize the diaphragm valve, and they name it diaphragm. So, just for this understanding this easily, we don't have to just think very different. That's we can just so from these pictures you can see the cross section is visibly. Okay, I have opted all the pictures which can be understandable easily. Okay, so we can assume that flow will flow from here. Okay, so this is the right now it is right now is it is on. Okay, so flow will not flow will not occur. It will resist the flow. Once we change the directions from here, okay, it will rotate initially and the passage to flow will be open. Okay, in diaphragm as we discussed, okay, the passage will be locked from here. If you can see, okay, passage will be locked here and it will resist the flow. Same will be applicable here, but here no spring or anything else will be contained. It has only a cross section that have a conical shape in it. It allows the fluid to flow from one direction to other. Plug valve is used for on-off services. It is oldest type of valve. Yes, it is very oldest type, and generally we are using it in our domestic uses also. The main part of valve are body. It is the body of valve. Okay, plug, it is called the plug of the valve, and the cover. Cover, it is the cover. Plug can be cylindrical or tapered. Actually it is cylindrical. The tapered will be narrow. Okay, it will have a narrow shape cross section area. The plug has a slit cut in it to allow fluid to flow. Here, that this is the cut, slit cut. It is called slit cut. It is an engineering word that allows the fluid to flow. Okay, the plug has slit cut to allow the fluid to flow. It provides a straight line and can be opened or closed just by giving quarter turn. As I told you, it requires only quarter turn. It requires only quarter turn from here to operate the valve and control the flow. Once it is moved, area will be open for the material to flow. I hope it is understandable. The plug valve have advantages such as quick action, easy operations, minimum space for installation, light in weight, and high capacity. Yes, it provides very tremendous still prevent the flow. Okay, it has very less components. As we can see, it is very simple in constructions comparatively. If we see the diaphragm valve, it looks like very complicated. Okay, this is also simple, but if we compare this butterfly valve with the plug valve, the butterfly valve looks very complex. Okay, same it is applicable here. Ball valve, it has also very good and easy constructions, easy understandable. Global is also very easy to understand, as we see. And yes, it has this lid cut. That is the reason it provides more efficient, comparatively more efficient and good flow resistance or flow control, we can say. Plugs wall are have advantages that switch quick actions. As we discussed, it requires only one motions from here, input here, and the work will be happen. Plug valves are available. Plug valves are available in size from 6 mm. Just imagine, it is available in 6 mm of size as to large of as 750 mm. So see, the range is very vast. Okay, it is also available in 6 mm. You can imagine how smaller it can be. The given data is for the cross section of pipe. Okay, so don't get confused. Okay, here we can see in the global it was minimum of 12 mm, that means 1 centimeter, 1.2 centimeter. Okay, in the gate wall it was of, it is not mentioned over here, it may be generally 20 mm. It will start from 20 mm too much. Yeah, 2.5 mm to it will start 2.5 centimeter. The ball wall is also generally starts from 60 mm. Butterfly wall is start from 50 mm. And we see this one, the diaphragm valve, it is started from 6 mm. Sorry, plug valve, it starts from 6 mm. So just imagine how accurate it can be and how we can utilize it very well in the very convenient place. It requires very low space to occupy comparatively. Okay, just because it is diaphragm, it contains diaphragm, so it has very more space to occupy, and it is comparatively costly also. That just because the diaphragm, we are using diaphragm in it. It has very simple construction, as we discussed earlier. Lubricated plug valve can be have high pressure rating up to 300 kg per centimeter square, and the temperature rating up to 300 Celsius. Okay, for the temperature, working temperature, it has very limitations. as we compare with the other previous valves. So here we can see the diaphragm valve was capable of working under 220 Celsius. Ball valve was able to work at 300 Celsius also. Gate valve was able to work at 675 Celsius also. So for this, it has some limitations in working temperature. But overall, if we say that this is the oldest type, as we discussed, it is the oldest type of valve. So now after that, they invented the different way to resist the flow and going on inventing different methods. So they introduced such valves. I hope this is understandable. Now coming to the next slide. This is needle valve. Okay, from the name we can consider that the one needle will be resist the flow. It is as simple as it. Okay, in the plug valve that we consider, this is plug, so they keep the name plugged valve. And in the needle valve, they're just having a needle disc to resist the flow. Needle valve contains a plug. The plug is tapered. Here we can see this is a tapered cut. Okay, tapered cut, and it is sights very accurately into sit. It sits very accurately. There's a sit of valve. Here you can see the two sits, and it fit into it very accurately. So the efficiency, if you compare the efficiency with globe valve, this comparatively both are similar. Okay, it will have good performance comparatively, but generally it is used in very small size of pipes. Here we can see that yes, the valves size are 3 mm. Just imagine, generally it is used in nitrogen lines, 3 mm to 25 mm, and can be used at temperature and pressure range up to 260 Celsius and 650 kg per centimeter respectively. Yes, see, the previous one was the plug valve was just able to work at 300 kg per centimeter square, and the needle valve is able to work at 650 kg per centimeter square, and the temperature is 260. Okay, the needle valve contains a plug. The plug is tapered, as discussed. This is tapered, but it sits very accurately. It has very minimum space, so it will fit into it very quick. The flow rate is regulated. The flow rate can be regulated. See, once if we rotate this, rotate this, and the linear motion will be occur. Okay, what will happen? It will allow minimum flow. Okay, controlled flow. We can say controlled flow to flow from here. Okay, I hope it is understandable. Okay, how much we will how the amount we will if we want, it can be called control flow also. Okay, we can have control flow also. If once we open this, okay, if you allow the passage minimum half of if we sorry, okay, if you allow this flow, okay, needle up to center of this, it's okay, flow will be start occurring. Okay, but in control manner. Okay, I hope it is understandable. The flow rate is regulated by an angular space between the tapered body and the plug and the seat. Okay, as I told you, it can be regulated. Okay, once we open it partially, it will remain partially, and the flow will be out partially. It is used for small and accurate flows. Okay, so I told you that it is already given over here that from the 3 mm pipes inner diameter, it is inner diameter. Okay, don't get confused. It is inner diameter of pipes. Whatever the dimensions I told you, okay, the size, wall size, that was the inner diameter of pipes. Okay, so 3 mm pipes to 25 mm. So just imagine how smaller it can be. Okay, and the reason it is smaller, the reason it is accurate more, just because this needle and the seats. The valve size varies from 3 mm to 25 mm and can be used in the temperature and pressure range up to 260 centimeter and 650 kg per centimeter square. Needle valve are used for controlling actuating air or hydraulic fluid for reducing pressure fluctuations. Okay. C. It is used for controlling and actuating the air. Okay. It can be also considered as a control valve, but generally the control valve is different. It can be controlled electronically, now also available. Hydraulically is also available. So it can be named, can't be named as a control valve, but all it is control valve. Needle valves are used for controlling and actuating air or hydraulic fluid for reducing pressure fluctuations. Material of the needle valve can be bronze, brass, and stainless steels. Okay. C. Okay. So this is the needle valve that complete here. The next is angle valve. Okay. So this is the I didn't get any cut section of the valve, so I placed the picture over here. Okay, I'll explain it. See, if the flow is coming from here, okay, the angle valve, it is having the same working as the globe valve. Okay, let me open this. If here you can see the cross section of globe valve. Okay, so the motions or the flow will be parallel. Okay, in that cross valve, okay, angle valve, the motion will be perpendicular. Right. So let's understand from this diagram. Okay. Let we consider this wheel, this controlling wheel, and the disc is provided over here. Okay. Parallel to the flow. It is provided parallel to the flow. Okay. Cross section will become like this, like S way. Okay. Cross section will become XS way. Okay. The flow is coming from this side to from left to right. Okay. Wheel is provided over here and the cross section will become like this, as shape. Okay, so what will happen, the disc will be oppose the flow or control the flow in the same direction with the flow is flowing. Okay, and once we operate the wheel, what will happen, the disc will create the passage or resist the flow. Okay, it will move this way. Okay, so what will happen, flow will be go there. Okay, flow will be transmitted vertically. Okay, it will be understable over here. Good. Okay, so as we discussed in the first page, okay, the flow will come. Okay, the wheel will be rotated, the passage will be open over here in the S shape. Okay, the disc will allow the fluid to flow in the directions perpendicularly. I hope it is understandable. It is quite difficult, that one, to understand. That's because I didn't have that diagram, that isometric diagram, but it's quite understandable easily from here. Okay, so now let's move to the pinch valve. It is similar to the globe valve as we discussed. Okay, angle valve. In the angle valve, the inlet and outlet ends are 90-degree to each other. Okay, the axis of steam is in line. Axis of steam is in line with one of the ends. Okay, here we can see there is a inlet of material. Okay, if you consider inlet of the material. Okay, and this is the wheel. The angle valve gives lower pressure drop and less pipe fitting in the piping systems. Okay, it is same as the globe valve. Okay, there is no just minor change that did over here. Just replace the just replace the disc from parallel to perpendicular. Sorry, perpendicular to from the parallel. Angle valves can be used for corrosive fluids, and it can have a single body or split body. Yeah, it is split body. So now this pinch valve. Here we can see there is a flexible element given over here. Okay, that what will happen, when we'll rotate the wheel, okay, when we will rotate the wheel, it will close the passage. It will minimize the area of passage and create the resistance to flow. It can be used for on-off and throttling operations. Yes, the valve has a sleeve. It's called sleeve, which is replaceable. This part will be replaceable. It's called sleeve. It can be used for handling slurries. Okay, when it requires slurries, it can be used. Its operations mechanism is completely isolated from fluid. Yes, it is very isolated. The rest are not isolated. This one is isolated. This eliminates problem of corrosions and contaminations. Sleeves can be made of rubber or plastic. This is the sleeve. It can be rubber. It can be made of rubber or from the plastics. Pinch valve can be designed for pressure up to 20 kg per centimeter square, not more than that. It has these limitations, working limitations. The temperature up to 250 Celsius. Working temperature is 250 only. If we compare this one, this needle valve, okay, it was having 260. Okay, pinch valve is not suitable for vacuum operations, right? Okay, so this butterfly valve can be used for vacuum operations, same as pinch valve cannot be used as for vacuum purpose. Okay, vacuum line. Slide valves. Here we can see it can be electronically operated or hydraulically. Okay, it is very simple constructions. It is used for controlling low pressure of flow of gases, liquid, substantious, and fluidized solids. It has parallel body sits between which the disc slides. Here you can see this is the body. Okay, this is the whole body, and the one plate is structured between this body. Okay, here you can see the nozzles. Okay, so once we connected with the pump or the pressurized fluid, what will happen? It will create linear movement of the this disc. Okay, so the passage will be open and close. It is very simple as gate valve. You can see in this in gate valve the same it was working. Okay, but here the hand wheel was given. It can be operated electronically also. Just we have to place motor over here. Okay, the same constructions and the same principle can be applicable here in this one. Okay, the shape and that all is different, but almost it is similar. Okay, same it was having a perpendicular flow resistance. Okay, and in this also we're having perpendicular resistance, but it can be used as a box type in the box cross sectional material flow. Okay, this is not compulsory that it will only work in pipelines and all this. Okay, if you want to transfer something like a coal and etc, okay, from one container to another, okay, it will also help. It will also utilize. It has two parallel body sits between which the disc slides. Okay, so the disc will slides as same as the gate valve, but it is advanced. We can consider it is okay. This because they have provided provisions of hydraulic or actuators. Okay, the disc act as a gate. Okay, it is can be considered as a gate. Your pressure drop offered by the slide valve is very low. Okay, so we can see the working capacity is 25 kg per centimeter square. That is very low comparatively. Okay, so it can't be used at the high pressure applications. Okay, it is available in size ranging from 50 to as large as 1500 So we can see here this is the maximum uh, valve size that we learned today. Okay, the previous one was the gate valve and the globe valve. Okay, and this is the maximum limit of valve that can be have maximum size. Okay, 150 mm. So just imagine that how large it can be. Okay, so it can be used for solid materials also. Okay, not compulsory that will only have applicable in fluid transformation only. Okay, it can be used for pressure up to 25 kg per centimeter square and the temperature up to 650 kg. Okay, so as I told you that it can be used to transfer any solid materials or semi-solid materials also. So that will be not easy to transfer from pipelines through. Okay, so this will be applicable there. So this was the types of valves, and still there are two remaining. It is control valve. Okay, so it is same looking as like a globe valve. Here, let me show you again. See, okay, the cross section and both are similar. If you see the cross section of globe valve, it is same. Okay, now the actuators and gauges are provided. Here is a diaphragm also. Okay, it is necessary for automatic process control system. Okay, it is actually very advanced valve and most expensive, one of the most expensive valve. It can be called as a flow control valve. Okay, it can be also get flow control valve. Okay, this is for very sensitive process or very hazardous process. Okay, so where the continuous inspections and all this thing is required, we utilize such valves to control the process and prevent for the preventions of any hazardous. Okay, it can be used either for controlling level, flow rate, temperature, and pressure, etc. So here you can understand it. This all can be controlled. Okay, controlling the level. Okay, how much the level is required to flow. Okay, if the valve is placed between pump to tank. Okay, the tank level is almost to get filled fully. Okay, so the signal, this valve will be get the signal from the control valve, sorry, control office, that the tank is almost going to full. Okay, so to required close minimize the flow, they will provide the signal and the work will be work will be happens. Okay, the flow will be resisted. It is called controlling leveling. Just for example, I explain flow rate. Okay, if the I will give you the same example. If the fluid is coming from pump and transferring into the any tanks. Okay, for storage tank. Okay, but the storage capacity. Okay, is have to be utilized. The storage capacity have to be utilized, and we required more time. You required more time to fill up the tank. Okay, so at that time we can control the flow also. Okay, in the previous one, the needle valve. Okay, the word was there that it can be controlled. Okay, regulated. The flow is regulated. Okay, and this all the characteristics are uh, in, okay, what say, are available. All the capability of this all valve are available in control valve to regulate, to control the flow, to control levels. Okay, so we can say that this is the most advanced types of valve. Okay, the flow rate as discussed, if we require the minimum flow rate, we can adjust electronically also. Okay, it will sense the temperature also, and required, if we required more control on pressures and temperature, it will change the flow rate and controlling. The selection of control valve involves its operation mechanism, process condition, as well as requirements. Yes, as I told you, this is the most expensive valve also. Okay, so this quietly used, as I told you, in limited applications. Okay, but where it is required, we must have to use it. Okay, to prevent the hazardous. Okay, the selection of control valve involves its operations mechanisms. Okay, so first we have to analyze what kind of why we where we can utilize this valve. Okay, for an example, let I tell you, if we want to control uh, air water. Okay, air water is used for hazardous purpose. Okay, so we need very accuracy and or very regularly checking or drills, okay, for fire water, um, for safety purpose, okay. So for generally it is may used in, I'm just giving an example, it is used in fire water safety, plus which or else the fluid which is very hazardous like acid, okay, acid, LP, can be used in LPG, but hazardous gas, I would say crude, okay. Crude is one of the hazardous also, okay. To process the crude, it requires control valve, okay, to transfer the quantity of crude in such manner, we require this control valve, okay. So it depend on the applications. If we go for service water, okay, we do the service water that can be utilized everywhere. So for that we don't need to use this control valve. Okay, at their applications we can use for gate valve also. That is very economic and simple. Okay, just because we know that service water is not for any hazardous purpose. It is for regular purpose. Okay, so these are the overview of valves. Okay, the main part of control valve are actuators. So here you can see the actuator is placed over here. In this, it is diaphragm. Okay, it will the processing unit. This is the processing unit. The process and the operation will be the what command will be given from the control control department. Okay, in industry, each department have their own control department. Control valve involves its operation mechanism, process conditions, as well as requirements, as I discussed. The main part of control valve. Okay, so the main parts of control are actuator and the body. Okay, this is the body, whole structure can say body. The signals from the process are received by the actuator. Accordingly, it closes and opens the valve. Okay, so I said that the signal will be processed. Okay, the signal will be transferred from control department for the concerned department. They will give commands to the valve to operate or open or close. Okay, according to their requirement. The size ranging from 3 mm, see, the size ranging from 3 mm to 500 mm and can be used for pressure up to 4000 kg per centimeter square, and the temperatures 50 kg, 250 Celsius to 800 Celsius. See, here you can see this is the most advanced valve they have still invented. Okay, the size starts from 3 mm pipe. Okay, just imagine the valve can be control flow of pipe which has only 3 mm inner diameter and maximum up to 500 mm. Okay, the pressure, working pressure can be up to 4000 kg per centimeter square. So just imagine how costlier it can be. Okay, the temperature is generally not the concern. Okay, same as 800, and there are previous many valves that having working temperature around 800. Okay, but the major concern is that it is having 4000 capacity of working pressure up to 4000 kg. That is really very very impressive things of this valve, and we have to that gone through. I would personally recommend everyone to just once understand about the control valve. Okay, and then last one is check valve. Okay, there is also combinations you can see of butterfly valve. Okay, they were providing that one butterfly sections also. Okay, it used to prevent flow reversal. Okay, fluid pressure keep the valve opens. Okay, it is closed either by pressures of fluid or by weight of the check system. It is used to prevent the flow reversal. It will provide only one way direction flow. Okay, it is also called non-return valves also, right? It is used for flow fluid velocities and where flow reversal is not frequent, right? Where the flow reversal is not frequent. Swing check valve can be used on the discharge side of the pressure relief valve. That is also another different way, terminology, pressure relief valve. It will having the same working as this angle valve. Okay, at pressure valve, a pressure regulating valve, what will happen if flow is coming from this? Okay, they will place a spring mechanism over here, over these sections, that the spring has designed in such way. Okay, if the pressure is fluid pressure is maximum, then it will allow the spring will be compressed and the flow will be having passage to flow ahead. Okay, that is also important thing. It is pressure relief valve, and the pressure, whenever the pressure will be reduced, the spring will take its original positions and the passage will be closed. Check valves are available in size ranging from 6 mm to 600 mm. They can be used for pressure up to 170 kg per centimeter square. Okay, the temperature up to 675 Celsius. The material of construction. So check valve can be cast iron, okay, ductile iron, and the corrosion resistance alloys. Okay, so it has a very simple constructions, but it is have its different applications. As I told you, it is required only one way directions flow. Okay, so these are the types of valves. Okay, now I would like to share one another things. Okay, apart from valves in the industry, the generally the diagrams, the symbols are used in isometric diagrams. Okay, we'll have a quick overview of it. Contains very gauges also. Here you can see there's a symbol of pressure gauges. Okay, this is for learning. Okay, there's a flow meter and can be mentioned in this way in isometric drawings or in it is called uh, typing an instrumentation diagram. Okay, that will be different. It is also called the language of PNID. Is it visible?
No, Parth.
Ravinder said it.
No, Parth. We just close the PPT and again this time.
Okay. Is it visible now, though?
Yeah.
Is it visible now?
No, it's now it's gone. Now again sharing the PPT. Okay, 1 minute.
Okay.
Now sharing again.
Okay, I'm doing it. Okay. So, is it visible now?
Yes.
Okay, thank you. So here we can see this is it can be called as a language diagram of instrumentations. Okay, it is pressure gauge and can be mentioned in this way. Okay, there is the arrow and symbolic. Okay, I have highlighted the main gauges that we can which are frequently uses in the process industry. Okay, here you can see the level controller, that is LC. Okay, the 65, that is a different name. Okay, that is maybe unit number. Okay, or it will be the 65th level control on the same line. Okay, it is requires numbers of gauges and controllers on the same line, so it can be a 65th level controller. Okay, here we can see the pressure transmitter. Okay, pressure transmitter is what it will sense the pressure and transmit to the control room. Okay, wherever you can see the pressure transmitter, temperature transmitter, it will collect the data of the concerned thing, that like pressure, temperature, and will transmit to the control department, so that control department can have overview and look and control on the each sections of the pipes. Okay, this is a very important thing. Here you can see Venturi meter that we already learned in our academic time, and we can mention in isometric or PNID this way. Okay, there is a flow indicator. This indicator means it will indicate at the same point, at that point where the gauge is installed. Okay, temperature controller. Okay, so this is controller. Okay, once temperature transmitter has transmit the data of at particular point to the control department, the control department will have the will operate the concern equipments to control the temperature. Okay, by operating valves and etc. Okay, flow transmitter. Okay, it is also most important thing. Flow transmitter that transmit the flow. Okay, how much the quantity of flow is been transferred, the data will be transferred to the control department to just analyze the process, whether they required anything changes, or if they required to control anything that they can control from the in that their control department. Okay, here that as discussed with types of valves, the valves can be symbolized in isometric this way. Okay, here we can see the check valve that we discussed. Okay, this is the butterfly valve. It is so easily identifiable that that plate will be rotate. Okay, the check valve. Okay, the needle type valve. Okay, you can remember easily. Okay, this is the hand operated globe valve. Globe valve was having a cross sectional like ball. Okay, so hand operated, that means they have provided a handle over here. Okay, the globe valve, that was simple. There is the global type of globe valve, right? The plug or valve, the plug valve that we discussed. Okay, it was having the similar slate cut. Okay, that this can be identifiable. There are a lot of, as I told, there are a lot types of valves are that we can see this three weight valve. Okay, there's a needle valve that we discussed earlier, right? There's a diaphragm valve. You can see the diaphragm disc like profile over here. Okay, so we can identify this is a diaphragm valve. Okay, and there are a lot of different gauges and the equipments are there. A lot of things are we have to discuss, but due to limitations of time, I will keep going fastly. Okay, so see, this is the compressor that can be mentioned in this way. Okay, this is the profile of compressors. Okay, rotary gear pumps that we learn also in turbocharger, also rotary type turbochargers. Okay, so this can be identifiable easily. These are the things that we can learn a lot. Okay, so now let's conclude. So hope that the webinar was very fruitful and very enjoyable. You may learn a lot of things, types of valve and all these things. I hope you are you got something you got learned something new today, and I'm very happy to be with you. Thank you very much, sir,
Thank you.
provide me the platform to share my
Thank
knowledge.
Okay, thank you, Parthias, for
Yes,
giving us such information about the different types of industrial valve and their symbol and their applications. So, thank you once again, behalf of Parul University, for sharing your experience and knowledge about this field.
yeah, thank you very much, sir. I would like to appreciate your efforts, as I told you.
Yes, sir. Okay.
Yeah, thank you very
Thank you.
much.
Thank
Yeah.
you. Thank you.
Yes.